Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. I invented a new supercomputer that could be used to solve the toughest problems arising in mathematics and physics. Such problems are called the grand challenge problems of supercomputing. Back in 1989, the year I completed my invention and began appearing in major US newspapers, Seymour Cray, who was the then leading mind in the world of vector processing supercomputers, could not understand the mathematics of where each of my 64 binary thousand initial boundary value problems should be and when it should be at each of my as many processors. Back in 1989, the supercomputer scientists that attempted to parallel process across an ensemble of processors were processing by the seat of their pants. That is, those supercomputer scientists of the 1970s and 80s did not understand the complicated mathematics and did not have the command of scientific materials and the subject matter knowledge that was needed to solve the grand challenge problem. The grand challenge problem was at the crossroad where calculus, algebra, physics, computing, and supercomputing met each other. Because they did not understand the grand challenge problem, the 25,000 vector processing supercomputer scientists of the 1980s and earlier began to hate the massively parallel processing supercomputer that I used to solve the grand challenge problem. Back in the 1980s, I was the only internet scientist that knew the 64 binary thousand or the 65,536 address tags that directed where on my internet each of my 65,536 initial boundary value problems of calculus and physics was delivered. To the 25,000 vector processing supercomputer scientists of the 1980s, reading my 65,536 email message passing codes was as incomprehensible as reading a Chinese newspaper. My invention of how to provide the address tags was the necessary precondition to the invention of the massively parallel processing supercomputer that is also a new internet de facto. That invention has rich and fertile consequences and contributed to the more complete understanding of how and why the technology called parallel processing or solving millions upon millions of problems across as many processors and solving them at the same time makes the computer faster and makes the supercomputer super. My quest for the precursor to the modern supercomputer that is fastest by parallel processing across a new internet, that is a new global network of processors, began as a vague idea. That quest began as the seed of an iroko tree and blossomed 16 years later into the world's fastest supercomputer that is the iroko tree of the unknown forest, named the massively parallel processing supercomputer. The iroko tree is the tallest tree in Igbo land of southeastern Nigeria. The iroko tree grows along the west coast of Africa. The iroko tree can live for up to 500 years. My quest for the parallel processing supercomputer began in the early morning of Thursday, June 20, 1974, in Corvallis, Oregon, United States. My quest for the modern supercomputer ended at 8:15 in the morning of Tuesday, the 4th of July, 1989, in Los Alamos, New Mexico, United States. That quest for the parallel processing supercomputer led to my deeper and surer understanding of the internet as a planetary supercomputer hopeful. I had ideas about parallel processing since 1974, but until the 4th of July 1989, I did not experimentally prove that parallel processing makes the impossible to compute possible to compute. My experimental discovery of parallel processing that occurred across my new internet, that is a new global network of 65,536 processors, occurred on the 4th of July, 1989. That invention of the parallel processing supercomputer was my lockdown evidence, and it was the first experimental confirmation of the beginning of new era in the world of supercomputing. That experimental discovery was processor agnostic and was node agnostic. My discovery of the parallel processing supercomputer made the news headlines because I successfully tested the new supercomputer and that I experimentally confirmed it as the world's fastest supercomputer. My invention of the parallel processing supercomputer went beyond theory to become an experiment-verified invention of a new supercomputer that is not a computer per se, but that is a new internet de facto. I, Philip Emeagwali, was the African supercomputer scientist that was in the news onward of my invention of the parallel processing supercomputer that occurred on the 4th of July 1989. I was in the news for inventing how and why a new ensemble of the slowest processors can be harnessed and be used to solve the toughest problems arising in both computational mathematics and computational physics, and how that new ensemble of the slowest processors can be harnessed and be used to solve computation-intensive problems that even the fastest vector processing supercomputer was unable to solve. Because I was in the news, Steve Jobs tried to reach me by telephone in June 1990. Steve Jobs and his computer programmers explored how they could increase the speed of their computers and increase them by incorporating the technology of the massively parallel processing supercomputer that I invented. Put differently, Steve Jobs wanted to know how I reduced 65,536 days or 108 years of time to solution on only one processor, and how I reduced that time to solution to only 1 day of time to solution across a new internet. That new internet that I invented is a new global network of 65,536 tightly coupled processors that emulates one seamless, cohesive computer that is a new supercomputer de facto. It was for a good reason that to massively parallel process and do so across a new ensemble of 65,536 processors was called the grand challenge problem of supercomputing. It was for a good reason that the June 14, 1976 issue of the Computer World magazine carried an article that ridiculed, mocked, and rejected the massively parallel processing supercomputer. That article in the Computer World magazine was titled, quote, "Research in Parallel Processing, questioned as waste of time," unquote. 32 years after that negative article in the Computer World magazine, Steve Jobs also questioned research in parallel processing, describing it as a huge waste of everybody's time. On June 9, 2008, Steve Jobs told the opening session of Apple's Worldwide Developers Conference in San Francisco, California, that his research computer scientists at his Apple Corporation questioned research in parallel processing as a huge waste of their time. As reported in the June 10, 2008 issue of the New York Times, Steve Jobs told Apple's worldwide developers that, quote, "The way the processor industry is going is to add more and more cores. But nobody knows how to program those things," unquote, Steve Jobs said. And Steve Jobs continued, quote, "I mean 2, yeah? 4, not really. 8, forget it," unquote. I invented the massively parallel processing supercomputer that Steve Jobs and his research computer scientists declared impossible to invent. The massively parallel processing technology is at the heart of the fastest supercomputer of today that hopefully will become the everyday computer of tomorrow. I experimentally discovered that the technology of massively parallel processing is a necessary condition for creating both the fastest computers and the fastest supercomputers. Since the programmable supercomputer was invented in 1946, we never invented a new supercomputer without first and foremost experimentally discovering faster supercomputer speeds. By the definition of the word computer, we will never invent a new supercomputer without first and foremost experimentally discovering a new fastest supercomputer speed. To achieve that grand wizardry in fastest massively parallel processing, supercomputing requires the visceral understanding that the massively parallel processing supercomputer is not a computer per se. I experimentally discovered that my massively parallel processing supercomputer that I visualized as a small global network of 65,536 commodity processors that were identical and that were equal distances apart is a small internet de facto. It's been said that out of the heart, the mouth speaks. I have spoken out of my heart. I have spoken a lot about supercomputers. I have spoken about the massively parallel processing supercomputer that I invented. I have spoken since the 1970s and spoken about how I was the first eyewitness to the experimental discovery of how and why a new ensemble of the slowest processors that computes together as one seamless, cohesive, massively parallel processing supercomputer is a new internet de facto. The words I spoke came from my discoveries, heart and brain. Those words will define me for posterity. To witness a discovery that has rich, fatal, and far-reaching consequences is like walking into a forest and witness a lot of leaves fall on your head. In a nutshell, this is my supercomputer story and my contribution to the development of the fastest supercomputer. I began programming supercomputers on June 20, 1974 in Corvallis, Oregon, United States. 2 years later, and in 1976, and at the National Computer Conference in New York City, a panel of supercomputer experts warned that parallel processing machines are, quote unquote, large and clumsy. That panel of supercomputer experts ridiculed, mocked, and rejected the then unproven technology of the massively parallel processing supercomputer. That panel of supercomputer experts offhandedly dismissed the technology of parallel processing as a huge waste of everybody's time. In the 1980s, I was dismissed from my research teams and dismissed for advocating the massively parallel processing supercomputer. In the 1980s, I could count the number of programmers that were massively parallel processing and count them on my fingers. But I needed only one finger to count them because I was the only person that was logged on 24/7 and logged on to the most massively parallel processing supercomputer ever manufactured. Today, the market value of that massively parallel processing supercomputer that I programmed alone has appreciated by a factor of 1,000. That new supercomputer that I programmed alone now costs the budget of a small nation. I experimentally programmed the new massively parallel processing supercomputer, and I programmed it alone. And I did so because the 25,000 vector processing supercomputer scientists of the 1980s were heeding the textbook warnings that it will forever remain experimentally impossible to harness the total theorized supercomputing power of an ensemble of thousands of processors. The supercomputing community's abandonment of the massively parallel processing supercomputer unintentionally created a certain cachet of exclusivity, and did so because they were de facto excluded from the frontier of human knowledge that was defined by the massively parallel processing supercomputer of the 1980s and earlier. The supercomputer textbooks of the 1970s and 80s cited Amdahl's law that was erroneously formulated in April 1967 and cited that incorrect law to argue that massively parallel processing across 64 binary thousand processors will forever remain impossible, or at least remain impractical. I'm Philip Emeagwali. I began supercomputing on June 20, 1974 at age 19 in Corvallis, Oregon, United States. Back in the 1970s and 80s, the core technology that drives both the modern computer and the massively parallel processing supercomputer of today and drives them at their fastest speeds was ridiculed, mocked, and rejected in scientific research. A scientist that discovered something new that other scientists did not know asserts his or her authority over his or her discovery, and do so by authoring an in-depth research report on his or her discovery and then giving a companion series of lectures that are shared with everybody in the world, including those on YouTube. My series of lectures on my contributions to the development of the modern supercomputer are posted at youtube.com/Emeagwali. The vector processing supercomputer scientists of the 1980s that I asked to review my 1,057-page research report on the new massively parallel processing supercomputer that I was programming ridiculed, mocked, and rejected my experimental discoveries and inventions. In late 1989, when my experimental discovery won the top prize in the field of supercomputing and began to make the news headlines across major US newspapers, those supercomputer scientists that ridiculed, mocked, and rejected my research report confessed to news journalists that they threw my 1,057-page supercomputer research report into the trash. After my experimental discovery of the massively parallel processing supercomputer that occurred on the 4th of July 1989, those supercomputer scientists that ridiculed, mocked, and rejected my discovery of the precursor of the modern supercomputer realized that the history of the supercomputer is unfolding right before their eyes, and that they were not a part of the story of the development of the modern supercomputer. In 1989, and after I won the top prize in supercomputing, those supercomputer scientists that ridiculed, mocked, and rejected my experimental discovery of parallel processing became envious of my new fame and ran back to me to beg for a second copy of my 1,057-page supercomputer research report that they previously threw into the trash. The news headlines described me as the African supercomputer wizard, and did so because my experimental discovery of the massively parallel processing supercomputer that occurred across a new internet, that is a new global network of 65,536 tightly coupled commonly available processors, and that occurred on the 4th of July 1989, was described as the wizardry act of making the previously impossible to compute possible to compute. What was erroneously written in the supercomputer textbooks of the 1940s through 80s was that it will forever remain impossible to harness the potential power of parallel processing. The June 14, 1976 issue of the Computer World magazine interviewed supercomputer experts that were attending the 1976 National Computer Conference in New York City. Those supercomputer experts were asked if it will ever be possible to invent how to use parallel processing, or how to use an ensemble of thousands of processors, and how to use them to execute the fastest computations across that ensemble. The unanimous opinion of those supercomputer scientists was summed up in an article in the June 14, 1976 issue of the Computer World magazine. E. Drake Lundell Jr., who was the computer industry editor for the Computer World magazine, wrote an article titled, quote, "Research in Parallel Processing, questioned as waste of time," unquote. Looking back retrospectively, the reason I was not discouraged from massively parallel processing across an ensemble of 65,536 processors was that I was then only 21 years old, and therefore I had the years to waste. It seemed like I was wasting 15 years onward of age 19, and wasting that prime decade and a half pursuing parallel processing that then seemed impossible. I spent the 13 years onward of 1976 conducting my supercomputer research and researching as a lone wolf at supercomputer centers that were across the United States. In the 1970s and 80s, I had a presence in US supercomputer centers. I programmed supercomputers in Corvallis, Oregon. I programmed supercomputers in Pasadena, California. I programmed supercomputers in Chicago, Illinois. I programmed supercomputers for 16 years, and I was the first person to be referred to as a supercomputer scientist. As an extreme scale computational physicist at the frontier of the supercomputer, my research focus was on how to invent a massively parallel processing supercomputer that I defined and outlined by a new ensemble of 65,536 tightly coupled commodity off-the-shelf processors, and how to reduce 180 computing years on only one processor that is solving the toughest problem in extreme scale computational physics to just one supercomputing day across my new internet that is a new global network of 65,536 tightly coupled processors that are harnessed to solve the same initial boundary value problem in modern calculus and or mathematical physics. 11 out of 10 people did not understand how I invented the precursor to the modern supercomputer. It was not I, Philip Emeagwali, that first reported my invention of the massively parallel processing supercomputer that computes faster than any vector processing supercomputer. My experimental discovery of how to parallel process an initial boundary value problem of calculus and physics, called extreme scale petroleum reservoir simulation, occurred on the 4th of July 1989. That experimental discovery of massively parallel processing was first reported by the Computer Society of the IEEE. The IEEE is the acronym for the Institute of Electrical and Electronics Engineers. The contributions to computational mathematics that arose from my experimental discovery of the parallel processing supercomputer was reported in the May 1990 issue of the Siam News. The Siam News is written by research mathematicians for research mathematicians. The Siam News is the flagship publication of Siam, the acronym for the Society for Industrial and Applied Mathematics. However, my new mathematical knowledge that the Siam News described as my mathematical contributions to computational mathematics was how the Siam News understood my mathematical discovery of 9 new partial differential equations of modern calculus and understood my mathematical invention of the companion 9 new partial difference equations of extreme scale algebra that approximated my 9 new partial differential equations. What the Siam News understood as my contributions to computational mathematics was not how I understood my invention. A discovery is like the moon that has 2 parts. the visible part and the hidden part. In 1989, the news media was reporting the concrete and the visible part of my experimental discovery of the massively parallel processing supercomputer and was ignoring the abstract and the invincible part of that discovery that occurred on the 4th of July, 1989. Back in 1977, I worked in the civil engineering field of highway construction. I did so for the state of Maryland, and I helped expand portions of the federal highway between Baltimore, Maryland, and Washington, D.C. 9 years later, I worked for the United States government. I worked as an engineering physicist that was responsible for updating 9 standard operating procedures. I used each standard operating procedure to safely operate each dam, and I used the procedure to safely control the water level of the reservoir that is upstream of the dam. And I used the procedure to operate the hydroelectric power plant within the dam. All the 9 dams that I worked on were located within the state of Wyoming. Wyoming is a state in the western region of the United States. Wyoming is defined by vast plains and by the Rocky Mountains. Wyoming is best known for epic cowboy and western movies and for its Yellowstone National Park. One of those 9 dams that I operated was the imposing 214 feet high Pathfinder Dam. Pathfinder was an arch dam that was a triumph of early 20th century design. Water cascaded from the mid-level outlet tunnel of the Pathfinder Dam. The Pathfinder Dam on the North Platte River of arid Wyoming is listed on the National Register of Historic Places. The North Platte is a river that rises in the snow melt of the Colorado Rocky Mountains. The 9 reservoirs in the state of Wyoming that I operated stored water that served the parched farmlands of Wyoming. Glendo Dam in the state of Wyoming is an earth-filled dam that is 190 feet high. Glendo Dam has a crest length of 2,096 feet. As a practicing engineering physicist at the Glendo Dam, I visualized the total amount of water that I controlled as follows. I had 800,000 acre-feet of water stored upstream of Glendo Dam. 1 acre-foot of water covers an acre of land to a depth of 1 foot. The term SOP is the United States Bureau of Reclamation's acronym for its standard operating procedure. In my SOP for Glendo Dam, the water storage capacity and the water redistribution is divided as follows: 100,000 acre-feet for farmland irrigation, 115,000 acre-feet to control sediment deposition, 275,000 acre-feet for controlling floods and avoiding dam break, and 310,000 acre-feet for producing hydroelectric power. Those engineering experiences aside, I was primarily a research engineer, not a practicing engineer. The difference is this: the practicing engineer likes to solve problems that are considered solvable, while the research engineer attempts to solve the toughest problems that were considered unsolvable. I was in the news headlines because I experimentally discovered that the impossible to compute is in fact possible to compute. A scientist becomes famous when he or she creates new knowledge or makes a discovery or an invention that creates new wealth and that makes the world a better place. For me, Philip Emeagwali, I defined solving the toughest problems arising at the frontier of engineering knowledge as the science and technology of using my knowledge of extreme scale algebra, abstract calculus, computational physics, and the massively parallel processing supercomputer, and using that knowledge in a never before seen way, and using that knowledge to solve extreme scale initial boundary value mathematical problems, and using that knowledge that helps build better bridges across my ancestral hometown of Onitsha, Nigeria, or to help design faster airplanes, safer ships, safer nuclear power plants, and even more fuel-efficient cars. The now ubiquitous technology of the massively parallel processing supercomputer that was scorned and rejected in the 1940s through 80s is used by practicing engineers and used to increase their productivity and used to reduce their time to market. A teacher asked her students, "What is Philip Emeagwali famous for?" I answered, "The riddle of parallel processing was experimentally solved by Philip Emeagwali in Los Alamos, New Mexico, United States, and experimentally solved at 8:15 in the morning of Tuesday, the 4th of July, 1989. That was the US Independence Day. That invention was my rock-solid proof and not a hunch that parallel processing makes computers faster. Doing many things at once, or supercomputing in parallel, became a surefire way to increase the speed of all modern supercomputers. My invention of the parallel processing supercomputer was my first major breakthrough in the world of science and technology. That invention was the milestone that put the name Philip Emeagwali into school reports. I experimentally discovered all the parallel processed speedup there was to discover. It's often said that the invention of the massively parallel processing supercomputer is the single most transformative technology and the biggest advance in physics since Newton Galileo. To invent a new computer or a never-before-seen internet demands genius, not luck or serendipity. I had no serendipitous invention of how to massively parallel process and how to compute across a new internet that is a new global network of millions upon millions of tightly coupled processors that are equal distances apart from each other. I visualized my small copy of the internet correctly. I visualized that never before seen internet a priori. My theoretical visualization enabled me to experimentally discover that the shape of the cube in the 16th dimensional hyperspace will give my new internet regular form and freedom. Each processor within my small copy of my new internet communicated via emails and along 16 mutually orthogonal directions and along as many dimensions of my imagined 16-dimensional universe. I visualized those 16 directions as mutually perpendicular and embedded within my imaginary 16-dimensional universe. Each processor within my small copy of the internet communicates in 16 directions and communicated by sending and receiving emails to and from its 16 nearest neighboring processors. My epiphany was my discovery that to execute the fastest computation, the deepest source of the massively parallel processing supercomputers' computing power was not in its 2 raised to power 16 or 64 binary thousand tightly coupled processors that actually computed. I theoretically and experimentally discovered that the deepest source of the power of the massively parallel processing supercomputer was in its 16 times 2 raised to power 16 or 1 binary million short regular email wires that did not compute. It took me 16 years of massively parallel processing and supercomputing across a new global network of processors to fully understand that my new frontier of supercomputer knowledge was a new internet de facto, not a new computer per se. I'm Philip Emeagwali. I'm not an overnight success in supercomputing. I began programming scalar processing supercomputers and began on Thursday, June 20, 1974, and began at 1800 Southwest Campus Way, Corvallis, Oregon, United States, and began at age 19. 3 weeks after I began supercomputing, I was on the front page of a local newspaper that was on the newsstands of the cities of Monmouth, Oregon, and Independence, Oregon. During my subsequent 16 years, I was ridiculed and abandoned in my supercomputer research. My quest was to invent a new massively parallel processing supercomputer that is a new internet. During the 16 years onward of June 20, 1974, I was shunned for challenging the dominant sequential processing supercomputer paradigm. It was on the 16th anniversary of my first foray into the world of the supercomputer, or on June 20, 1990, that the Wall Street Journal reported that I, Philip Emeagwali, has figured out how to make the impossible to compute possible to compute. Namely, I figured out how to massively parallel process and figured out how to compute across a new ensemble of processors that shared nothing with each other. That invention of a new supercomputer made the news headlines because it was transformative and translational and opened the door to a new era in computer science. For the 43 years onward of 1946, the massively parallel processing supercomputer was ignored and misunderstood by the computer science community after my invention of the 4th of July 1989. The enabling technology of parallel processing is embodied into every modern computer and is universally used to increase the speed of the fastest supercomputers in the world. I figured out how to synchronously communicate across a new global network of 1,048,576 email wires, and I figured out how to simultaneously compute on 65,536 processors. But it took me 60 years to become the overnight success that I was portrayed in the major US newspapers, such as the June 20, 1990 issue of the Wall Street Journal. Back in the 1980s, there was arguably only one massively parallel processing supercomputer in the world. That massively parallel processing supercomputer was powered by 64 binary 1,000 tightly coupled processors that were identical and that shared nothing between each other. That massively parallel processing ensemble of 64 binary 1,000 processors only allowed one supercomputer programmer to lock all its 65,536 tightly coupled processors and lock those 2 raised to power 16 processors simultaneously. So I was logged onto my massively parallel processing supercomputer and logged on 16 hours a day. I was even running supercomputer codes while I slept. I have been married since August 15, 1981. In my marriage, the supercomputer was the other woman. In the 1980s, it was impossible to have a second modern supercomputer scientist that was massively parallel processing across an ensemble of 65,536 processors. I knew that I, Philip Emeagwali, was the only full-time programmer of the most massively parallel processing machine ever built. In the 1980s, I was standing alone at the farthest known frontier of supercomputing, and I had a sense that I was onto something that was bigger than myself. I was confident that I had the best chance of figuring out how to massively parallel process across a new internet that is a new global network of 65,536 processors. I was confident because I had 16 years of supercomputing experience that began on June 20, 1974 in Corvallis, Oregon, United States. I was confident because a few insiders believed that I could invent how to massively parallel process or how to solve many problems at once instead of solving only one problem at a time. The reason every supercomputer programmer hopeful, except I, Philip Emeagwali, abandoned the massively parallel processing supercomputer hopeful was that naysayers said that the message passing programming of an ensemble of millions upon millions of processors was akin to looking at God in the face. During my quest for the fastest supercomputer, I felt like I was walking alone along a small road with a small lamp. In the 1970s and 80s, it was often said that parallel processing is a huge waste of everybody's time. As a lone wolf supercomputer scientist, my grand challenge was to draw the massively parallel processing supercomputing power that I needed to record the fastest computational speed in the history of the computer. That fastest speed that I recorded at 8:15 in the morning of the 4th of July 1989 in Los Alamos, New Mexico, United States was the reason major newspapers called me the African supercomputer wizard. The wizard in the unknown world of the massively parallel processing supercomputer must command all 65,536 tightly coupled processors. That wizard must control all 1,048,576 bidirectional email pathways that married those processors together as one seamless, cohesive supercomputer that is a new internet de facto. Back in the 1970s and 80s, I was excited because I was the unknown supercomputer wizard. I was excited because I locked all 64 binary thousand commodity processors and locked all 1 binary million commodity email wires. I was excited because I locked the entire parallel processing machine and locked them at all times. The year that I locked my massively parallel processing supercomputer was 1989. The place that I locked my massively parallel processing supercomputer was Los Alamos, New Mexico, United States. Looking back to the National Computer Conference that took place in June 1976 in New York City, a panel of supercomputer experts ridiculed the massively parallel processing supercomputer hopeful and dismissed the technology as large and clumsy and dismissed it as a huge waste of everybody's time. So my research in parallel processing was science fiction to the attendees of that National Computer Conference of 1976. In the 1970s and 80s, I drew my inspiration from half-human cyborgs that I imagined as super-intelligent lizards of year million that will colonize outer space and that are half year million computers and half year million posthumans, and that will make our science fiction their year million non-fiction. I theorized that the technology of massively parallel processing will be at the core of the brain power of the half-human cyborgs of the fourth millennium. I theorized that each half-human cyborg will talk to 1 trillion cyborgs and will communicate in real time and will compute together to make our science fiction their non-fiction. You hear about a half-human cyborg, but I had always imagined that by year million, trillions upon trillions of immortal post-human cyborgs could roam our Milky Way galaxy and do so to accomplish what seems impossible to humans. Those post-humans of year million will be half-humans because they could compute and communicate in parallel. The sequential processing, that's the massively parallel processing supercomputer that is programmable across an ensemble of processors, became faster than any supercomputer after my experimental discovery that occurred on the 4th of July 1989. The modern supercomputer that occupies the space of a soccer field and costs the budget of a small nation is a completely different beast from the everyday computer. The universe is huge and is 13.82 billion years old. The supercomputer is small when compared to the universe, We're modeling the universe. We cannot squeeze the universe into a supercomputer. I'm Philip Emeagwali. I am a supercomputer scientist with the spirit of a mathematician and the soul of a physicist. That is, I encode some laws of physics into some equations of calculus that I, in turn, discretize into equations of algebra that I further converted into an equivalent set of floating point operations of arithmetic. On the 4th of July 1989, I figured out how to speed up an ensemble of processors that outlined a new internet and how to speed it up by a factor of 65,536 or more. That invention is my contribution to the development of the computer. Thank you. Thank you. Thank you very much.
Insightful and brilliant lecture.
Thank you.
Insightful and brilliant lecture.